Hey everyone, welcome back to the channel. Today I'm excited to show you an amazing CoppeliaSim library that makes testing your Arduino projects super easy, no hardware needed. Whether you're working with sensors, motors, or custom controllers, this library helps you simulate everything before deploying to real hardware. Let's jump right in. First, you'll need to download the library. It's completely free, but if you find it useful, consider supporting me via the Buy Me a Coffee link in the description. Once downloaded, just unzip the file. Inside, you'll find an Arduino folder. Copy this into your CoppeliaSim models directory, usually at C program. Files Coppelia, Robotics, CoppeliaSim EDU models. After that, launch CoppeliaSim, and you'll see the new Arduino folder in the model browser. That's it, ready to go. Okay, now that our library is set up, let's build our virtual robot step by step. Here's how we'll assemble all the components. First, we'll drag the Arduino Uno model from the library into the scene. This will act as the brain of our robot, just like in a real-world setup. Next, we'll import the robot plate. This will serve as the base for our robot. All other components will be mounted onto this plate. Now we'll place the L298N motor driver onto the robot plate. This driver will control our DC motors, allowing us to move the robot forward, backward, or turn. We need to make sure the Arduino and the L298N are centered and properly aligned on the robot plate. This keeps our setup neat and ensures everything works as intended. Here's a crucial step. We'll set the Arduino and the L298N as children of the robot plate. This means when the plate moves, all attached components move with it, just like a real robot. Now we'll add the two standard Arduino wheels. Each wheel must be attached to a force sensor. Adjust the wheel's position and height to ensure it touches the ground properly. This step is key for accurate movement simulation. Before attaching the second wheel, we need to flip it. Why? Because in a real robot, the wheels are mirrored to ensure symmetrical movement. Just like we did with the first wheel, we'll fine-tune the position and height of the second yellow wheel. Make sure both wheels are aligned symmetrically. Now that our robot's physical structure is ready, it's time to wire everything up and configure the components for proper control. Here's how we'll do it. Each model in our library comes with a graphical user interface, GUI, where we can define its behavior and connections. To wire the components, we'll specify which Arduino pin controls each part. For example, the L298N driver needs 4 input pins, IN1, IN2, IN3, IN4, for motor direction, and PWM pins for speed control. In the GUI, set the pin type to ARI output, analog output, since we're using PWM signals to control motor speed. Each component also has an ID. This is crucial when you have multiple sensors or drivers in the same scene. The ID ensures CoppeliaSim knows exactly which device to communicate with. Open the L298N's GUI and specify its unique ID, as well as the IDs of the 2 wheels it's controlling. This links the driver to the correct motors. Don't forget to click Apply after making any changes. Otherwise, your settings won't be saved. Since we imported the same wheel model twice, we must assign a unique ID to each one in their GUIs. And since we mirrored the second wheel, we need to reverse its rotation direction in the GUI. Simply check the reverse rotation box. Otherwise, the wheels will spin in opposite directions, and your robot won't move straight. Now that our robot is fully assembled and wired, it's time to bring it to life with code. We'll write a simple Python script to control the robot's movement, just like programming a real Arduino, but in simulation. Under the Arduino model, you'll find 2 script files, one for Python and one for Lua. For this example, we'll use Python, but the logic is the same for Lua. Open the Python script. You'll see all the available functions listed, mimicking real Arduino functions like digital write or analog write. Our goal is simple. Make the robot move forward for 5 seconds, then backward. Here's how we'll structure the code. To make our robot move properly, we need to create dedicated functions for each type of movement. Let me walk you through how these work. First, we have the move forward function. This function takes a speed value between 0 and 255, which controls the motor power using PWM. When called, it sets pins in 11 and in 21 to PWM speed, while setting in 12 and in 22 to 0. This configuration makes both wheels rotate forward at the specified speed. Next is the move backward function. This works similarly, but reverses the motor polarity. It sets in 12 and in 22 to PWM speed, while in 11 and in 21 goes 0. This reversal makes both wheels spin backward at our chosen speed. For turning movements, we have 2 separate functions. The turn left function works by keeping the right wheel moving forward, while the left wheel either stops or slows down significantly. This speed difference between the wheels causes the robot to pivot left. The same principle applies to the turn right function, just mirrored. Here, the left wheel continues moving forward, while the right wheel stops or slows, making the robot turn to the right. Now that we've defined all our movement functions, the final step is to call them inside the main while loop. This is where we put everything together, telling the robot exactly when to move forward, backward, and voila! The script runs perfectly, and our virtual robot moves exactly as programmed. No hardware headaches, no wiring mishaps, just pure simulation magic. A huge thank you to all of you for watching. We pour a lot of passion into creating these libraries and sharing them with the incredible CoppeliaSim community. If you have any questions, run into any snags, or just want to share what you build, drop a comment below.